Very good. So let's officially start with this webinar. Welcome everyone to today's webinar where we will talk about the fastest way to create professional 3D model with a 3D survey software. So from beginner-friendly automation to advanced 3D modeling techniques. So if you're thinking about starting with photogrammetry but don't know where to begin, this webinar is perfect introduction for you. So should be super nice and exciting. As already mentioned, the webinar is going to be recorded, so you will be able to see the recording. And let's continue with my PowerPoint presentation. What's today's plan? So in this session, we will guide you through the simple and most automated way how to create the high quality 3D models. So no complex step, just import your photos, set up the batch processing option to define your workflow and click run. So your 3D model will be automatically generated from the images. So Mattia will show you this workflow in the next part of the webinar. Then the second part, I will describe you a few tips and tricks so how the most effectively map your area of interest to get the best 3D results. So this will be in the second part of the webinar. And then last but not least, just a second, we will cover an advanced workflow, a step-by-step approach where you will have full control over each stage of the processing. So we will go slowly then step by step from the bundle adjustment, orientation, dense reconstruction, and so on, and try to describe those parameters a bit that you will have a good feeling. And yes, before we go right deep into it, so I would like to share presentation screen to Mattia, and we'll first start with a short survey about the attendees. Okay, feel free, Mattia.
Yeah, hello everybody, also from my side. Well, to get to know you a bit better, I have prepared just 3 quick questions for you, which I will start right now. So, first question is really simple. Are you already a 3D survey user? Even if you use just the trial version, this also counts. And results are coming in. Okay, almost 70% of you already voted.
Yes, very good, 76%.
Nice. Okay, nice to see you're also responsive. Okay. Are we ready for the next one? Anybody still want to vote? Yeah, still coming. All right. I see some late arrivals are dropping in the webinar now. So if you only joined us now, you jumped right into the questions. Okay, I think we have enough votes now. I will go to the next one. All right. So,
okay, maybe just a short feedback, Matthias. So based on statistics, 60% are existing users and 40% not yet. So we have a great audience here.
Great.
Very good. So let's continue with the second question.
Okay. Now, what's your goal for creating 3D models? So what's your main objective you want to achieve when you start out to create a 3D model with 3D survey? So it can be done with either a drone, camera, or photogrammetry, doesn't matter. We're interested in what you want to get out of when you do a 3D model. Is this more for visualization, creating digital twins? Or maybe you are a classic surveyor who wants to up their game and make their life easier. Maybe you deal more with volume calculation. This one's popular in mining, as we know. Or maybe you're a bit of a CAD enthusiast, maybe you're an architect who wants to do more vectorization or something that wasn't defined here. If you want to let us know what that other is, there are also questions and comments. So you can post that. So we got a 80% of you already voted. Okay, so as we can see, survey measurement is taking a lead because we're 3D survey, that makes sense. Close behind is visualization. And then third place is CAD and vectorization.
Okay, we also get some feedback for survey during in the chat box. So some of you would like to have multiple answers. Yes, fully understand, but we just want to go quickly. So with a single option, the most popular for you, the most interesting for you currently.
Okay, and the last question for you now is, which parameter do you consider most important in your photogrammetry workflow? Is it speed, accuracy, learning curve, so meaning the level of knowledge you need to understand the software, or quality of 3D model, so how good it looks, or maybe you're more interested in the features that come with the software when you create your 3D models. So okay. I guess here depends on what you want to achieve. All of those are nice to be in one software, but it's hard to be strong on 5 edges. So it's good to have some feedback on that also.
Okay, 70% already voted.
Okay, I guess results are not that surprising. About 50% of you bet on accuracy. That's makes sense because we've seen a lot of surveying feedback in the previous 2 questions.
Very good feedback.
Then second place is quality of 3D model. Of course, it has to look nice. It has to look as a digital twin to be high fidelity. Then there are integrated features and speed with 6% each. And the learning curve or the level of knowledge needed is just below 10%. 9% of you voted for that one. And this is actually the most targeted option of today's webinar, alongside with the speed as well. So thank you for your votes. Now we won't torture you anymore. We'll continue with our content. So we can close this. Okay, Marco, are we ready? Can I start with my part?
Yes, feel free to continue with your part of presentation.
Okay, I have prepared a video for the first part, and just before I jump into that video, I would like to mention what you need to prepare before you start your project in 3D survey. So there is not much actually. You just need to copy all your images that you got from your drone or your camera into one folder on your computer. And then let me just start this video. Okay. Okay, so as I said, select all your images and upload them, import them into 3D survey software. Click open and they will be loaded into 3D survey. Now you will see the telemetry importer window. You select coordinate system here, just click import. Then you see telemetry window, which will give you some information about accuracy, precision, and location of your images. You can also visualize that if you click the telemetry button up there. So these are the locations of all our images taken for our 3D model. But the focus is on batch processing. So project, batch processing. You may have not known that this button is right there. When you click it, this window pops up. It gives you the steps of all that are possible in this processing. So first one is bundle adjustment. Second one is orientation. And the third one is dense reconstruction. Here we set the level of reconstruction. The first one will change something is mesh calculation. So here we'll change it to full 3D mesh because that's what we want today. And down here you can set some parameters for the quality. For example, max triangles will put in 10 million, so we'll have really nice and accurate model. And orthophoto calculation will just uncheck because we don't need it today. And then you just press run. It's that simple. So now you can just sit back and let the computer do all the work. So as you have seen in this video, which I've also slowed down a bit, we have used less than 2 minutes to set everything as we need it. And now the processing will go on without our input, without any of our interference. So it will take about 2 hours to calculate this project. It has more than 600 images. And this one is sped up now, of course. The first process that will be completed will be bundle adjustment. This means image matching. So the images will be now recognized and they will form a sparse point cloud of tie points. We will see it in a few seconds on our screen now. This step is mandatory. Yeah.
Yes, so maybe for your feeling, the bundle adjustment step is pretty fast in most cases. So I think for these 670 images, it took about 25 minutes or something like that.
Yeah, a bit less.
This is a decent desktop computer. On average laptop computer, you should get in a half hour or something like that for that kind of data set.
Yeah. So the next big step is dense reconstruction. This one is probably the most important in 3D survey when we are reconstructing 3D models. It will give you dense point cloud with millions of points, which may already represent your 3D model. For those who are really new to this, it's like maybe compared to a laser scanner. So we'll see it in a few seconds. So we mapped a building there in the center, and we also got a few other buildings. The program will auto-save your progress when this is completed, and it will automatically go to the next step, which is full 3D mesh, which is what we want to get to in today's webinar. So just a few more seconds, and here it is. This is the 3D model. You may not have seen it so good in the video, but that's why I have also prepared this project for you in 3D survey window. Can you see it now? I think it should be, yeah.
We can see it, so we can see your screen.
Perhaps the platform will lag a bit, so we'll try to go slow. Okay, so this is the 3D model we got out of our 660 something photos without any input from us. So the message we want to convey today is that you don't need a lot of time sitting behind a computer or a lot of knowledge to produce such 3D models. 3D survey does it all for you. And as you see, this model has been done very nice because we have some nice edges of the roof, even here with the underhangs, overhangs. The texture is looking really nice. And, you know, the 3D survey part is actually the easy part. And that's why we have built this webinar today in the fashion that Mark will now show you some tips and tricks for when you're on field, when you're mapping with your drone, to be to pay attention to get such a model. If you just fly over it and make 100 nadir photos, it will not look like this. You may get a not so satisfying results. So, Marco, I give the word back to you.
Okay, thank you, Matthias. So very nice short presentation. So we see the fully automatic process. This is also what is described here in point 1. So you just import the images, preset your steps, click on run, and that's it. So super simple and effective. And now I would like to show you what you need to do to get that kind of a nice 3D model, okay? Because this was one building example, our area of interest was a single host, and if you have that kind of scenarios, you can super decently map this on a field. So everything starts already on a field. If you have good input data for 3D survey, you can also get good end results. And here are actually the 5 quick tips from 3D survey site, what you need to take in mind when you are mapping your object of interest on a field. And definitely point number 1 is beside nadir images. Okay, wait, PowerPoint again. So beside nadir images, take at least circles around your area of interest with the side images. So if you would like to get a nice 3D model, just perpendicular images down are not good enough. You need some side images. And you can see those blue pyramids are camera position where all images were triggered. If you take 500 images per house in this way, you should get similar results in 3D survey. Okay. When you do this,
if I may, sorry, Marco, if I may add here, when you start on top, you are perpendicular, and then you go down and you increase that angle slightly. You shouldn't just go with too big of an angle, because those images may not connect well. So start the first ellipse with, I don't know, 10 or 15%, and then go 20, 25, 30.
Okay, yes, Mattia, thank you for adding this. So yes, you need to connect nadir images with a bit of side images, and every circle it's more horizontal. So the first one is, I think, minus 25 degrees, then minus 35 degrees, and at the end you come to 45 degrees angle or something like that. Okay, and when you are doing circles, you are triggering images every 10 to 15 degrees. So you have approximately 50 to 60 images on a specific circle. And also, when you do this, you adjust the height. So if you fly it with nadir images on 40 meters, do the first circle on 30 meters, the second circle on 20 meters, the third circle on 15 meters or something like that. Okay. You could do this with the automatic mode flight or just manually flying around your object of interest and trigger images every 2 seconds or manually. Depends what you prefer. Okay, then point number 2, turn your camera up. This will give you nice roof edges with minimum artifacts. So most of the drones offers also to turning a bit your camera up. So this will help you to get the details also under the roof edges. And with this kind of data as an input, we are able then also create a good point cloud under the roof. And in the next step, good 3D mesh with that kind of examples. If you just do with the nadir images, you will probably have some balloons close to the roof edges and so on. If you make a bit more attention also to this kind of areas, you can cover really nicely also roof edges in similar areas.
Yeah, you have to remember that if you don't see it, the 3D model cannot reconstruct it.
You don't get it, exactly. And you need to have it on more images, usually on at least 5 images, the same detail. Okay, then point number 3 I would like to emphasize here is focus on hidden objects. So usually you have a lot of vegetation, cars, and everything around your object of interest. Just keep in mind that you need to capture at least 5 to 10 images also from a specific part if you like to get it. So in our case, the backside of house was covered with the vegetation, and we go really closely to get also those ACs and garbage boxes and cars and everything what's there. So those blue pyramids, which you can see it now, are all camera positions. So we fly manually and capture them from 10 meters to, I don't know, to 1 meter close to the house. So really closely. Take care when you're flying with drones, but most of them are super stable and this shouldn't be too hard for you. Okay, and then the fourth point, take care also of vegetation. So what does it mean? So if you would like to have a nice blending 3D models, the vegetation also adds a lot of effect here. So if you will forget about the biggest tree which is close to the building and you will have hole in this model, you're just not going to get the complete nice model out of it. Okay, so in this case you need to fly also high enough to capture the top of the trees to recreate 3D model of vegetation. And the same like with all other objects, you need to have them from more camera positions to reconstruct them successfully. If there is a windy weather during the mapping, this could be sometimes tricky because the vegetation is usually moving, and then this will be a bit harder for software to detect those positions on the same areas, but depends on the weather, definitely.
It's most important. Have a nice weather.
Yes, have a nice weather. Also, sunny weather helps you to have a positive colors and everything like that. If you're doing this for visualization, everything is important. Okay, and point number 5, camera settings. So here is a simple advice to all users. So we advise you to, at the beginning, use auto mode for the beginners because it's just the safest way to get some results. Later on, when you capture 5 to 10 projects or something like that, that you're more mature with this, how to preset up, we would suggest you to have a shutter priority, to set up shutter priority option where you define the shutter speed and all other parameters are then adjusted automatically. And with the shutter priority, it's like so. So if you're doing mapping, if you're mapping during the winter times, once per 100 is the longest time you should have it. Otherwise, the images are blurry. And this will probably cover the most cases in a low light condition during the winter time. During the summertime, you will probably use, where you have a lot of lights, you will probably use 1 per 1000 of a second. But we have also these instructions in our webpage, so you can check it out later. Yes, Mattia?
Maybe you can also learn these numbers for shutter speed. When you do those projects where you set it on auto, go check what shutter speed the drone used, especially if you're satisfied with the images and the project. Go check what shutter speed the drone set, and then you'll get a feeling what to use. If you were on a sunny day, maybe it used 1 through 2000, and in bad lighting, maybe it used 1 through 400 or something like that. Check those settings. They're available in EXIF readers, so maybe you can learn something from that also.
Okay, very good. So now I think it's a good time for maybe first questions, if there are some, about the batch processing approach. Just to remember you again, under the project, batch processing, and here you defined all the steps. So if there are some questions, please feel free to write them now there that we are able to answer it. And I'm just spending 10 more seconds to showing you these results, and also maybe camera positions where these were captured. So these above were from Nadir images from the automatic single grid flight. Then if you see here is my first circle, here is my second circle, and here is my third circle. And then I go a bit lower. I didn't complete the fourth circle because of tree here, but in this way, you can really nicely map the entire area. And as you can see it also here on the backside, how many images I produce. So all those blue pyramids are actually image positions. So let me maybe switch also on an image to see just how the input images looks like. So this was these were images from the circles. Let's go a bit below, so even closer. Let's find more closer images also. Okay, you see this one is with the turned up camera. So also in this way, it's great to capture it. And this gives us then the material to recreate also details under the roof or something like that. Okay. I special focus also on this lower part. This was all manual flight, more or less. So I hope you have a good idea how we map all this. Okay, before we
Marco,
continue,
we got our first question.
Okay.
Do you want to?
Okay. First question is, what do you recommend for the number of triangles? Default is 2000. Okay, let me extend a bit. Sorry, yes, default is 2 millions. Yes, that's true. So in most cases, actually 2 millions is good enough. Let me check. Yes. So for most cases, 2 millions is good enough. You can go up to 10 millions easily. So as you can see, this mesh is calculated with 10 millions triangles. So this gives you a bit more, even a bit more details. But it depends maybe also what is around your object of interest. So if you have a lot of vegetation, a lot of trees, they takes number of triangles. So in this case, you will need to increase the numbers of triangles. If there is more urban area with more buildings, so already 2 million.
Mapping roads, 2 million is already more than enough.
Yeah, more than enough, exactly. But I would move it here between 2 and 10 millions of triangles. Okay, so this is definitely a good decision. Okay, next question. What is the best approach of combining photos and point clouds? Mattia, do you understand this one?
Yeah, this one's a bit advanced. So if I understand correctly, Evgenius wants to know if how to combine, for example, photogrammetry and laser scans. This can be done. The most important part is to have some ground control points, tie points, to align those two models together. If you have those, or even if you don't, you have to make sure that the two models will cover at least 3 points that are easy recognizable on both of them, and then you can combine them together in a 3D survey. We have made this possible with Transform tool or the scan module.
Okay, very good. So if there are some questions in addition, feel free to write them. We will answer them at the end of the webinar. And let's now continue with our standard topic. Right now we are already at point 3 of our presentation. So we will cover an advanced approach now of workflow, where step-by-step approach will be shown with the full control over the stages, and we will try to explain some of the parameters there that you understand how the software works. Where are some tricks that maybe needs to be solved during the processing. And I have here my example of construction site, actually, where I will show where I will go step by step. That we are not going to wait too long for all the processing step. I was switching between already calculated project and with the new project. So right now, I would like to open another 3D survey on, and I will start the same like Matthias started, so with the new project. Here I will select my images, click on open, and as you saw it before, we have a first telemetry.
Marco, you can go a bit slower on this part where I went really fast.
Yes,
so
this is my plan. Thank you. This
maybe
is my plan.
explain a bit more. We just ran through this one.
Yes, so the first is telemetry importer window. What's important in this in this step, you define your project coordinate system. So the coordinate system you would like to have your end results. And you need to set this one correctly here at the beginning, because all the results then will be in this coordinate system. You have some options to do the transforming later on and everything, but the most easiest way is that you select here the right coordinate system of your country. And with 3.0 version, we release the completely new project coordinate system support, and it's actually super easy to use. So you just need to type your country name, like Slovenia, because this is in Slovenia, and you get the preset for your country. So in Slovenia is just a single preset here. If I click my preset Slovenia D69TM, I immediately get preset horizontal coordinate system, vertical coordinate system, and also with GeoIT file will need to be used for the correct transforming of the coordinates. GeoIT files are also automatically downloaded from our database, so you don't need to import them. We support probably most of them. If you need some special one, you can contact on support. But in this way, this is like a one-click selection and click import, and that's it. If we just check for Austria, you see you have 3 of them. Central, oh sorry. Yeah, Australia have more of them. Austria have 3 of them. Germany. So you have those presets inside, so you don't even need to know too much about the coordinate system. Nevertheless, if you would like your own one, you can select here from the list from 5,000 coordinate system. You can search it with the help of search and anything like that, and preset everything up. Okay, what's important to know? We cover most of the coordinate system presets. If you need some help, feel free to contact us. Okay, let's go back to Slovenia to set the right one, like so, and click on import. As you saw already before with Mattia, we get here the coordinates from drone, transform coordinates. Here is the AGL flying height we used. It was actually 60 meters, and also the accuracy during the data acquisition. This was captured with the RTK drone. The previous model, the house model, which Matthias shows you, was also captured with Mavic 3A with RTK model. We didn't use in previous case any ground control points for orientation. We will mention also this part, and I'm just confirming this one, close it, and I can see my image positions here. On the right side, there is the total number of images selected and so on. So you have all the important data. And the next step I have here is bundle adjustment. And first you have 3 different approaches. I wouldn't spend too much time here. In 99%, the global is the good one. If you're doing some photogrammetry project or something like that, sometimes incremental helps you out, but let's leave it with global. If you click on show more, you get a bit more technically data. And here is the most important, maybe maximum detected feature and the feature detection level. So when you need to change this, in case you get from 140 images registered just 40 of images or 20 of images, you will probably need to increase this number of feature detection and put this one from number to high or from high to extreme. This could happen if you have a lot of vegetation, higher trees or something like that, or if you're mapping a lot of water areas, okay?
Maybe
But
on the other hand, if you're processing a lot of images with what you know is a good overlap, like 80 or 90%, you can also decrease this number and your processing time will be shorter.
that's true. That's fully true. Okay, and if I click OK now, the processing will start it. It would take probably 10 to 15 minutes for this example. We are not going to wait for this part, so I will switch to my already recalculated project. And as you saw it from the batch process already, you get that kind of a sparse point cloud here. Let me reset the orientation to lose the orientation data here. So we see that the ground control points are not yet on the right position. And the next step after the bundle adjustment, it's orientation step. Let me check with the batch processing. So with the orientation step, you can do the orientation on telemetry data. So on the just on the data that drone gives you, where the blue pyramids are. If this is a RTK data set, this is already pretty good. But nevertheless, we always advise to use at least 1 to 4 ground control points to have really accurate results, because sometimes the height of the 3D model the differences between 10 to 30 centimeters if you are not using ground control points, because the drone GPS, it's nevertheless not so stable than survey grade GPS, GNSS, and so on. So if you're doing some volumetric or you need to compare your survey results with traditional survey results, keep in mind to have some ground control points, or at least adjust your photogrammetry model to the exact height. And what I was trying to tell you here, even if you're doing orientation in batch processing, you could do the orientation with the help of ground control points, okay? But what's important, your ground control points are 3D survey targets, so black dots on white plate, or checkerboards or APERTAG. So those targets we are able to detect automatically, and the complete process can be performed fully automatically. This is first important point. Second important point here is that you have your telemetry data and ground control points in the same coordinate system. So coordinate system, the ground control points needs to be on the exact height, on the exact coordinate system that your drone data, and with the help of GeoID, grid and shift files, this is possible. But of course, you need to have an RTK drone, okay? And then you can also perform the orientation here automatically. Nevertheless, if we do this with the manual way, I click on orientation, orientate with ground control points. Here is circle predefined. When I go to the next point, I will see here, let me go, that, oh, sorry, I was too fast maybe, that because I have the telemetry data, the ground control points are close already to the ground control points. So this was my GNSS measurement, and this was ground control points. The searching radius is here 1 meter. So if the green circle is in a 1 meter radius, we will later on find this target. And I think this is good enough. So let's find also another here. So this is also good enough. So because we have aligned telemetry data and ground control point data, this should be fine. So here is even better. I think if you have your own examples, this should be even nicer. And when I go here to the next step, most of the targets should be automatically detected. So like we can see it here. If I would correct those positions a bit better in a previous step, I would have even better results. But nevertheless, already here with no user interactions, most of the targets are detected. And probably we have a tutorial and everything how to improve this step even more. But let's leave it.
So Marco,
yes.
You can actually use this also in batch processing.
That's my point. So if you have our 3D survey targets, or if you have a checkerboard or Apertex, you can do this with a fully automatic way also in a batch processing.
Great.
Great. What's different here? If you go step by step, you just have more control. Okay, so you can decide and go one step back before, improve this, or correct the positions in this step and get results maybe a bit better in comparison with the batch approach. But nevertheless, here we have all the results. Because it's a small area, a lot of ground control points, the orientation accuracy is around 1 centimeter. And now we see the model is orientated with the help of ground control points also. Okay, so we finished the bundle adjustment, we finished the orientation. Next step, if we go step by step, it's reconstruction step. Default parameters are like you see it here. So the reconstruction level is high. This is kind of a best time performance. So 3D survey really calculates a nice point cloud out of it. With the high level, you get a great results in most cases. What is important, it's great to have an NVIDIA graphic card, then this is checked on and this works nicely. With the high preset and with the standard graphic cards like 4070, you can handle 100 images per hour. If you have 2 or 3 graphic cards, you can go from 200 to 300 images per hour on a high level. You can go even harder to extreme, the time is double the time of the high and so on, or with a medium or lower level, which is 4 times faster than at the end. Okay,
this is
so
perhaps similar to the question of how many triangles do we need. So if you're doing just road or flat surfaces, you don't need to go high even.
Exactly. If you want to hurry, go on medium. Even low will generate you almost good enough data. But if you would like to produce a nice 3D model for visualization, I would go with high. Okay, I will click on cancel because we don't have 1 hour and a half time. And after the dense reconstruction, we get a point cloud like that. Okay. So in this case, 41 million. And what is next step from this point cloud? We can go here up to mesh and decide what kind of mesh we would like to calculate it out. So 3 options are available. The first one is DSM or regular grid mesh, which is perfect for volume calculations and contour lines, and traditional orthophoto. Okay, I will show this one in the second approach. Then the second option is full 3D mesh. This is the mesh Mattia already showed you with the nice holes. Here we also have this mesh, so it's a nice visualization mesh. Here also just with the nadir images, also pretty good 3D model, okay, to see all the details out of it. And it was fully automatically calculated. And then the third option is triangulate mesh from CAD data. This is in case you would have a survey point with a total station or GNSS device, and you would create a mesh with big triangles. So not interesting for my part right now. So you can define all those steps also in a batch processing. Like Mattia quickly showed you before, regular grid mesh is for volumes and contour lines and through orthophoto. He select a full 3D mesh. Okay. Okay.
Maybe Marco, on this point, we could emphasize why is it beneficial to go manually over this, since batch processing does not support
Here is a
step.
Exactly. There is a setback of the batch processing. So what you're not able to do with the batch processing, you're not able to classify point clouds on terrain points and everything else. So that's why you need, if you need to do the classification that you calculate the digital terrain model, you need a user interaction here and click on classification feature. Why? Because our classification work with the help of one ground control point, which you saw manually to the software, and then all other points are actually generated based on this parameter. So when I click classification, I get classification parameter, which are good enough for 95% of the project. So let's just go next and confirm them. And I select one ground point where I'm 100% sure this is not house, vegetation, or building, or something like that. And most of the other are detected. Next. Additional classification run. In addition, I click finish, and now all the red colored points are recommended as a ground points. So when I delete the unassigned, when I uncheck the unassigned point, you see all those points are just terrain points. If I change the parameters a bit here, where I lose a bit of terrain, I could get also these things inside. So what you will need to do for this, I will just quickly show you maybe, because it's also an interesting topic. So I will smaller the grid cell size, and I will just increase this parameter. So regular grid cell size, I will set to 20 centimeters, smoothing factor to 0, and increase the smoothing max distance, let's say, to 8 centimeters. So now we are doing classification with the help of surfaces. Now this surface will be closer to the point cloud we calculated in 3D survey, and more details will be recognized there. Okay. Okay, let's cancel this one. But we also have a nice description of this feature in some PDF document. If you're interested, you can find on our webpage. Okay.
Marco, maybe you could show how quick we can calculate the DSM out of this one.
Okay, let's do also the next step. Before you saw the full 3D mesh, now the DSM, which is a regular grid mesh, I will set up the 0.5 meter grid triangle size, no smoothing, and click on calculate. And this should be really super fast. So in a few seconds, I turn off the full 3D mesh here, and this is, show grid. This is now the triangle surface. And as I already mentioned, it's perfect for volume calculation, perfect for true traditional orthophoto calculation, and perfect for calculating the contour lines. So if I take 1 meter contour lines here, this should be also super quick. So to have it here and see the contour lines here in action. Wow. If you like to smooth out those contour lines, make a smoother DSM, and contour lines will be nicer. Okay. Very good. So this was my point by point. Okay, so next step is just orthophoto, but this is the topic for another webinar. So I would stop here by my presentation step by step. It's already 10 minutes to 1 hour, so I think it was quite intensive. Mattia, would you like to add something before we go to the next batch of informations?
I think it was a really nice, rounded presentation of how quick you can process your photogrammetry data. And as you mentioned, when you get this 3D model, there's so much more you can do in the CAD engine that's integrated in 3D survey. And we have also seen the contour lines. But we could have a webinar for 3 or 4 hours if we wanted to go over all the features. So I think, yeah, it's best. It's the good spot to finish with content for today and maybe focus on some announcement and finally the questions.
Okay. So very good. So we would just like to remind you at the end that the Black Friday is coming. It's super close to us. So we also offer some special price for the perpetual 3D survey license for subscription and for both models, so from the scan and videogrammetry module. So the special promotion price is valid from 20th November till 18th of December. So please feel free to check it out on our webpage and see what's happening there. So yes, don't forget to do this. And yes, we also decide that we will have another webinar in December. So feel free to subscribe to our newsletter if you still didn't do it, to get the notification about this info, what's happening. So we would like to share even more knowledge with you in the future, and yes, help you to produce your model nice, sharp, and smooth. Okay.
Yeah, for this next webinar, please stay tuned because it's a special one. We will not tell you what's so special about it, but you will find out soon. But it's good to be informed early.
Okay, so I think this was everything what we want to share today with you about today's webinar. Now, if there are some questions, let's spend 10 minutes more to answer them.
Yes, Marco, there's
And
quite some
yes,
questions already.
feel free maybe to write your questions in the question box if you'd like to know something in addition, or you need. Okay.
So some of those have already been answered. Do you want me to read them and you can answer?
Yes, let's do it this way. Yes.
Okay.
If you can help me with this.
So you can still type in your questions while we start on those who are already here. So Arthur has a question. Any way to smooth a wall or road to do not have to vary surface? So the problem where you get a road that's not smooth. What can we do there?
Yes. So if you are talking about the DSM level, so DSM model, this is kind of a super easy. Let me check what kind of road do we have here. Maybe also, yes, maybe you can see some holes also here in the road. So there are a number of options. Okay, the one is just selecting the area around the uneven terrain and click flatten. Okay, in this way you can correct point by point uneven terrain. So what's the algorithm behind it? You select your area of interest, and based on the round selection, we try to define the most smoothed surface out of it. Okay, so if you're doing it this way, this will be super smooth. Then another option, more general option, is if I go back to the point cloud. As you can see, because of the burnout images, the road was here not calculated perfectly, and we have some noise here in the point cloud. If I would eliminate these points already before, the DSM would be better and the results will be immediately good one. Otherwise, if I go here to mesh, regular grid mesh, and I do a bit of, I do here a bit of smoothing. So let's say 3 cells. This is kind of mediana filter. So we take the center cell of your area of interest and take 3 cells left and 3 cells right and try to connect the most smoothest surface out of it. So this means at the end that you will get more smoother surface here. So
okay,
let me.
Thank you, Marco. We have quite some more questions. I think this one answers the problem.
Okay, very good.
We can see a more smooth surface here. Then Daniel has a question. He wants to detect the hail damage on car roof. And sometimes they encounter very subtle impacts, like 2.5 millimeters. Do you think we can achieve this level of accuracy?
So yeah, so the car material is super tricky for the photogrammetry because it's always shining a bit. So if you go super close, so I would do this with the hand shots with a good camera and maybe in some special environment where you limited the effect of lights and everything, and maybe even something more, some kind of powder that give you texture on the car. This could help you. So even laser scanners could have issues with it kind of stuff. Okay, so it's kind of super tricky, super hard. You can try it out. If you do everything correctly, I'm sure you would be able, but depends if it is worth.
Yeah, it's not a problem of 2.5 millimeter of accuracy. It's the problem of the surface because it's just too reflective. So Nuth has an interesting question. He wants to do cadastral work in 3D survey, and he's interested if there are countries that use 3D survey for cadastral work.
So we are integrating more and more functionalities in our 3D survey. And as you know, you can import cadastral map in the 3D survey and use it to select some special area of interest, maybe for volume calculations or so for something like that. With the next release, we will also have an option to adjust the height of the cadastral measurements to the surfaces. So move CAD to the mesh level actually, so it will be even nicer also for those kind of data. But for specific cadastral work where you need to, I don't know, do the cadastral, so like a boundary. So I would say like so. They're using cadastral, they're using 3D survey for basic beginner measurements to have the opportunity to adjust the cataster to the orthophoto or to 3D mesh, and later on for visualization, something like that. But all those complex transformation with the cataster, you know, to adjusting the specific part of the cataster to different area, this is not covered inside. So definitely. So part of it, yes, but yes. And also it's super specific. Every country has its own cadastral software for cadastral measurements, and you know they have to have specific formats. So it's a super niche. We are working on this, but nevertheless, probably you will need to take your own software for cadastral measurements at the end also.
So then Anton has a question whether we will implement Gaussian splatting, if that is planned.
Yeah, so we know what it is. We make a research of this one, and we did some tests. So it's not on short plan, development plan, because it's still a super nice way for visualization, but it's hard to get, hard to extract out the lines and points from this approach. And that's why we are not so orientated in this direction, but fully agree with you, it's maybe the nicest way for visualization. I would never say never. Let's see where this technology goes, okay? Definitely we have to do a lot of different stuff before.
Marco, I think you will like this one. Tobias is asking, there are always bubbles under street lamps in 3D models. Support says it's the algorithm. When will new algorithm for reconstruction come out?
Yes, very nice, very nice. So it's top secret, but we are working on it. So we know the limitations of our algorithm. So when you have a small details like power line cables or traffic lights or something like that, let's focus here on a bit. This is kind of limitation, okay? So you get an, okay, but let's note this is not a point of interest. So these were just from the side images.
If you took more images of that lamp, it
Yes,
will also look better.
of course, but nevertheless, this is the limitation and we are working on this one. So this is super complex thing. I'm not able to say right now, but I could say we are working on it, we are aware of it, and this will be next super nice improvements of 3D survey.
Then there's Mark. Do you have anything else?
Yeah, what I was trying to say here, what could improve this is if you focus on improving the point clouds. So you see here is a lot of noise beside the traffic lights. You could use like select by color feature, okay? And before definitely focus just on area close to the lamp, so with the bounding box. And if you eliminate those points, which are kind of noise points from these details, you could get a better 3D model also. So this one, but this is manual work, not easy. If you need, it's worth to do it.
Yeah, the main answer is we're working hard on the new algorithm that is top secret. So if we continue, Martin is asking, will there be planned webinar for videogrammetry soon? We'll write this down, right?
We will write this down, but nevertheless, go to our web page. We have some webinars already recorded for videogrammetry.
Yeah, there's already one.
There's already one recorded. There are some good tutorials about this one. And feel free to write us an email, maybe what you would like to see on the webinar connection with.
Maybe there are new devices coming out, and maybe we could test them and do some webinar on
Martin,
that.
please send us an email with your ideas, and yes, we will take in mind. Yes.
Okay, so then there's Tom. Easy answer for you, Tom. Where can I find more information about classification function? There are tutorials online on our YouTube channel. And also, if you write to support, Reed has some tips and tricks up his sleeve also.
Yes, and I think we prepared not long ago some kind of special PDF document about the classification. Not sure if it's already on web page. We need to put it on. But yes, we can share this one with you, Tom. Shoot us an email.
In the coming days, it should be online. Yeah. Thanks for reminding us, Tom. Okay, then there's Ray. It will be fine if you give MRS classification, point cloud, and parameters. Okay, so Ray is asking for a webinar on classification. That's also a good idea. Okay, then there's a question from Bastian. What do you mean by true orthophoto and standard orthophoto? Probably true and traditional is
okay. So super quickly one. With the true orthophoto, you have a orthogonal. Okay, with the true orthophoto, you get the roof on the right locations. With the traditional orthophoto, buildings are always turned a bit of beside. Okay, because the traditional orthophoto you are doing with the ground terrain model, so digital ground model. With the true orthophoto, you are doing with the full 3D mesh, so all the buildings are inside, and then the projection of the image goes to the exact height, to the exact mesh, and with this you will get the nice roof positions also. So our general advice is actually, if you have urban areas, you need to calculate true orthophoto. if you have like a construction site without buildings, or I don't know, big areas in the middle of fields with no buildings, nothing there, so just grown terrain with some vegetation, do traditional orthophoto. The benefits of traditional is you get a bit better texture, so you see a bit more detail in comparison with the true orthophoto, and it's faster to calculate it.
Okay, thank you, Marco. Then we have Vincent. What could be the cause of exported DSM in text format to have easting and northing coordinate signs inverted? This is with Heart 94 coordinate system.
Okay, Vincent, feel free to write this one to support. So we will support you with this one. It's connected with the predefinition on the coordinate system right at the beginning.
Yeah, but you will get step-by-step solution if you write this to 3D survey support. Okay, then there's Gunnar. Fine house. Doing the pictures by drone manual slide below 3 circle. So yeah, Gunnar's asking if it was flown manually.
Yes, all those. So in this example, just the highest images were captured automatically and everything else was manually. So it's safer to fly manually close to the building because, you know, the GPS helps you to hold the drone on a stable position. You have time, you can focus it. So just for your idea, this model was captured in less than 20 minutes. So this is a half of the battery and that's it. It's nothing hard, shouldn't be too hard.
Okay, next one is Wojtek. Is it possible to do whole building with rooms in full 3D mesh using SLAM scanner?
Very good question. Yes, of course, it's possible. So you combine interior with exterior. I have actually one example here from interior. We use kind of a not expensive SLAM solution or something like that. So Matterport, which doesn't give you the most accurate results.
And while you are loading, maybe you can answer the next one. Is Insta360 supported?
So it's going to be in the next version with the help of scan module. You will be able to import panoramic images also in 3D survey and combine panoramic images with the point clouds. So for now, not, because it's a spherical camera. You're not going to be able to calculate 3D models with the help of 360 images, because when we did those tests, the accuracy and the noise is quite big, because those are not very powerful images with the resolution and everything. But it's a super effective combination when you observe the spherical images and see the point cloud behind, and you can actually draw on image, on spherical image, and snap on point cloud. And this is kind of powerful, and this will be part of the scan module in the next release.
Okay, then we have what is the best way to draw a building wall with CAD tool by Tobias?
Oh, very good. Okay, let me just show you this previous one where we have interior.
So this is similar to SLAM scanner.
Yes, let's say similar to SLAM scanner. We have also a lot of SLAM projects here, but yes.
So this was combined in 3D survey. Both of them were imported in 3D survey and then combined.
So here you have no exterior and interior, and you can combine them easily. The easiest way with the
scan module,
manual registration. This is the easiest way. The another option is to transform or move the object on the right position or already have it. But yes. if you have the scan model, you select your model from the drone, you select your model from the interior, and then focus on at least three same locations and show 3 identical points and so on. Okay, so it's possible. Yes, Mattia, what was the next question?
Yeah, sorry. What is the best way to draw a building wall with CAD tool?
Okay, building wall. So you have more options. One option is to use a custom plane orthophoto or side orthophoto, and then draw in third part software this building wall out of it. Another option is, to draw it in a CAD tool. Let me just
You
prepare
can do
my
it in 3D survey.
Of course. So to go to CAD module and draw it, turn on the cameras and draw it like that. But because I have a test version right now, let me show you the hidden things. So define plane, you are not able to see this in your versions.
So this is a teaser for the new one.
This is a teaser for the version. So we add the option to add plane, and then you can easily draw on this plane. So all the windows will be on the exact same plane. So the vectorization is much easier with this one. Of course, few tricks needs to be done here in addition, and in this way you can do the vectorization super simple. Okay, let me increase those parameters a bit that you will also see what's happening. So like in this way, right now I'm drawing on my design plane.
You could do more effort and also correct your positions on the images on the left side.
Exactly. And this is one approach, and another approach is, to go to our X-ray algorithm. So go to our webpage and check these things out. So let me just show you where you can find this. Okay, webinar is over. So you have scan here, and this is another approach. So check out these videos, X-ray views, and so on. So we also have all the tutorials for this part, nicely covered. Okay.
Okay. So then the next question is actually for me from Marco. Do you plan to make a user manual? I'm working on it, Marco. Thank you. It's not the most fun thing to do, but we are working on it. Should be done before the next version. Yes, I know many of you are expecting it. So yeah, we'll take care that it's done. Then there's Tom again. How do I crop the mesh to remove areas outside the building that are not of interest?
So this is also super simple.
Yeah, you have more options actually.
When we have also more options, exactly. So the one option is, if you don't want to lose the data, it's using the bounding box. On the right, or if you go on a corner, right mouse click, you can rotate this bounding box. Right mouse click to move the bounding box, the plane of the bounding box, and with this focus on area of interest, like so. Okay. And even when you turn off the bounding box, you are now working just on your area of interest. Okay. So this is one option. When you click again the bounding box, you can change the things again and so on. If you click the reset view, you go to default view, and from the other side, what you can do when you go to mesh, you can just quickly select of your area of interest. Takes a couple of seconds to select all the triangles, and then instead of delete selected, click on delete other. Okay, don't make mistake here because you don't have an undo button here right now. Cool. So this can take 3 hours of additional processing if you click wrongly. So, but
Yeah,
it's a nice inverse function. And with this, I actually eliminate away everything else. Now I have just 2.9 million triangles, and if I like, I can work on this one. So this is the fastest way.
Yeah. There's also clip function that allows you to clip it through CAD.
Exactly. So right mouse click, clip, very good one. If you have a boundary with some kind of close polyline, you can import it and so on. Yes. Number of options.
We only have one more question left from Wojtek. What is the best setting for the full 3D mesh to get the result of the interior?
So to getting the mesh of the material depends what kind of source you have as an input. If you have a SLAM or laser scanner, it's kind of pretty the same like with the photogrammetry, but depends of the input. So if you have a good point cloud, you will get also a nice mesh from interior. What's great to have it if you have option import point cloud with normals. Okay, this really help us to create nice interior mesh from inside. If you don't have point normals from an interior, you first need to calculate them and then calculate the mesh. But this is a more time-consuming process, and the results are not so nice. That in comparison, you have normals as a default. But nevertheless, again, when you go to mesh, full 3D mesh, and let's say this would be a point cloud from interior, I would start with height 2 million, and if you have images, so take the full resolution. If no, go without texture. So maybe good advice when you do that kind of project from interior, first calculate mesh without texturization. This is super quick, okay? So it could be in 10-15 minutes. If you have 500 images, the texturization will take half an hour. So first do a mesh with points, see what comes out. If you're satisfied, then just go here, right click on mesh and click where is calculate texture. So calculate texture and do this step. So you can do this processing step in 2 steps actually. Okay. Okay.
Great.
Very good. Not to be too long. Thank you for your patience, guys. Still a lot of attendees are listening, so interesting. Mattia, do we have more questions, or we are close to this one?
Actually, we got 2 more. So, okay, maybe we can answer also these 2. Does the software work well with big data sets, such as over 10,000 images?
Good question. So I would go with 5,000 images maximum per project. And for 5,000 images, you need kind of professional setup. So it means 128 gigabyte of memory. I would have 2 graphic cards or something like that. And then you can work with this. If you have 10,000 images, so our biggest data set was actually 9,000 images. It goes well, but it took quite a lot of time. So more effective is maybe to split in 2 separated projects, process 1 project separately, second project separately, and later on join the results or something like that.
And now the really final question from Anton. He has some problems with X-ray. When I use X-ray, my vector falls into unbelievable plane. Is there something to fix this? Anton, it would probably be best if you write to support to see what exactly is going on there.
But with X-ray, if you're talking about with the X-ray of scan module, the plane height is defined with the red line when you're creating layouts and sections. This should work normally. If not, let us know. Right.
Adjust the red line, and if it doesn't work, write us on support. Okay, thank you, everybody. That was quite a lot of questions.
Quite intense.
Don't forget, we're doing another webinar in a month. So think about what would you like to see there, maybe.
Okay, very good. Let's start with promotion and then, yes. Okay, yes, and once again, Black Friday, if you like to wait a bit, so 6 more days.
It's coming next week on 3D survey already.
Exactly, and yes, happy to host you all today. Thank you for your attendance. We love to share our knowledge, which we have, and happy to see you next time.
Yeah, happy 3D surveying.
Thank you for today. Bye-bye.
Goodbye, everybody.